In the vast, echoing emptiness of interstellar space, far from the warmth and light of any star, wander celestial nomads. These are the rogue planets, shrouded in darkness and mystery. Our galaxy, the Milky Way, is teeming with billions upon billions of stars, each a potential sun. Yet, for these rogue planets, there is no sun to call their own. They drift through the cosmos, orphans of the universe, their origins and their fate, a captivating enigma. Rogue planets, also known as interstellar planets, free-floating planets, or orphan planets, are celestial bodies that share characteristics with the planets we know from our solar system. They are large enough to be rounded by their own gravity, but unlike the planets in our solar system, they are not bound to the gravitational pull of a star. Instead, they wander through the galaxy, adrift in the interstellar void. These planets are shrouded in darkness, their surfaces cold and desolate, devoid of the life-giving warmth of a sun. They emit no light of their own, making their detection a formidable challenge for astronomers. Their existence was long theorized, but only in recent decades have advancements in astronomical instruments and techniques allowed us to confirm their presence in the cosmos. The origins of rogue planets are as diverse as the planets themselves. They likely arise from a variety of cosmic scenarios, each leaving its own imprint on the planet's characteristics and trajectory. One prevailing theory suggests that rogue planets are born in the chaotic early stages of star system formation. Within the swirling disks of gas and dust that surround young stars, planets coalesce from the accumulating debris. This process is a delicate dance of gravity and momentum, and sometimes the gravitational interactions between forming planets can become unstable. When this happens, a planet might be ejected from the nascent star system, flung out into interstellar space to become a rogue planet. Once a planet is ejected from its star system or forms independently in interstellar space, it embarks on a solitary journey through the cosmos. This interstellar odyssey is a testament to the planet's resilience, its ability to endure the harsh conditions of the interstellar void. Without the warmth of a sun, a rogue planet's surface is frigid, its temperatures hovering just a few degrees above absolute zero. Its atmosphere, if it ever had one, would likely have frozen over, coating the surface in a layer of icy volatiles. Yet beneath this frozen exterior, some rogue planets may harbor a hidden secret, a subsurface ocean of liquid water kept warm by the planet's internal heat. The journey of a rogue planet is governed by the gravitational forces of the galaxy. It might drift through the Milky Way's spiral arms, encountering pockets of dense interstellar gas and dust, or it might traverse the vast emptiness between the stars, its trajectory influenced by the cumulative gravitational pull of distant stars and galaxies. Throughout its interstellar voyage, a rogue planet is exposed to the cosmic rays and interstellar winds that permeate the galaxy. These high-energy particles bombard the planet's surface, altering its chemistry and leaving behind a record of its journey through the cosmos. By studying these traces, scientists can piece together the rogue planet's path through the galaxy, unraveling the story of its interstellar odyssey. The vastness of interstellar space makes it statistically unlikely that a rogue planet would directly collide with a star or another planet. However, the gravitational influence of a rogue planet passing through our solar system could have profound implications for the orbits of the planets and other celestial bodies within it. If a rogue planet were to pass close enough to our solar system, its gravitational pull could disrupt the delicate balance of our planetary neighborhood. The outer planets with their more distant orbits would be most susceptible to this gravitational perturbation. Their orbits could be elongated, shifted, or even ejected from the solar system altogether. The effects on the inner planets, including Earth, would be less dramatic but still significant. The rogue planet's gravity could alter Earth's orbit slightly, potentially affecting our planet's climate and seasons over long periods. Such a gravitational disruption could also stir up the asteroid belt and the Oort cloud, sending comets and asteroids hurtling towards the inner solar system. While the passage of a rogue planet through our solar system is a rare event, it highlights the interconnectedness of the cosmos, demonstrating how even distant celestial bodies can exert their influence across vast stretches of space and time. It underscores the fragility of our planetary system and the powerful forces that govern the celestial dance of planets and stars. The study of rogue planets is a frontier of astronomical research, filled with challenges and opportunities. Detecting these dark, solitary wanderers is a complex task, demanding innovative techniques and advanced instruments. Astronomers rely on gravitational microlensing, a phenomenon predicted by Einstein's theory of general relativity, to identify rogue planets. When a rogue planet passes in front of a distant star, its gravity bends the starlight, acting like a lens and temporarily magnifying the star's brightness. By carefully analyzing these subtle changes in starlight, astronomers can infer the presence of a rogue planet and estimate its mass. Future telescopes, both ground-based and space-based, promise to revolutionize our understanding of rogue planets. These advanced instruments will be able to detect fainter microlensing events, enabling the discovery of smaller rogue planets and providing more precise measurements of their mass and distance. As we continue to refine our observational techniques and develop new technologies, we can expect a surge in the number of detected rogue planets. This wealth of data will allow astronomers to better understand the origins, characteristics, and distribution of these celestial wanderers, shedding light on their role in the grand scheme of the cosmos. The quest to understand rogue planets is a testament to humanity's insatiable curiosity about the universe. These enigmatic wanderers challenge our preconceived notions about planetary systems, stellar dynamics, and the very nature of the cosmos. Their existence hints at a universe far more complex and dynamic than we once imagined, a cosmic stage where planets can be flung from their stellar nurseries and embark on solitary journeys through interstellar space. The study of rogue planets is not merely an academic pursuit. These wanderers hold clues about the processes of planetary formation, the evolution of star systems, and the distribution of matter in the galaxy. Their exploration deepens our understanding of the cosmos and our place within it, inspiring a sense of awe and wonder at the vastness and complexity of the universe. As we continue to probe the mysteries of rogue planets, we embark on a journey of discovery, pushing the boundaries of human knowledge and venturing into uncharted territories of the cosmos. The quest to understand these celestial wanderers is a testament to our shared human spirit of exploration, our innate desire to comprehend the universe and our place within its grand design. The cosmos is replete with mysteries, and the rogue planets are but one of its many enigmas. Yet with each new discovery, with each step we take towards understanding these celestial wanderers, we come closer to unraveling the secrets of the universe. The quest to explore the cosmos is a journey without end, a testament to the boundless wonders that await us in the vast expanse of space and time.